There you
Great,
go.
okay, we're doing question 2. A golfer hits a ball from point O on the horizontal ground with velocity 55 at an angle of 20 above the horizontal. The ball first hits the ground at point A and the time of flight is t seconds. Assuming that there is no air resistance, calculate the value of t and distance OA. So I think it's helpful, isn't it, to draw. There's your initial velocity of 55 meters per second at an angle of 20 degrees. And so what have we got going on with this? We've got the components. We need the components of the velocity. Just remembered what we did. So there you've got that component would be 55 cos 20, and that one is 55 sine 20. It's helpful to split it into the components. We've got to think about the time of flight. So the time of flight, which one did I do first? Yeah, I did that one first. That is how long it takes to get back to the start point. So if we're thinking about just the vertical direction, we've got an initial velocity, we've got a total displacement of 0, so we're going to use S equals ut plus half at squared. Our displacement is going to be 0. We've got the vertical component of the velocity times t minus a half at squared. That's a half gt squared, wouldn't it be? So minus a half times g times t squared. So we've just got a simple quadratic equation. Common factor t, we'll take t out. 55 sine 20 minus 4.9t, which tells us that it was at that start position at the ground level when t was 0. We knew that already. And when t was 55 sine 20 over 4.9, and that gives us 3.84. Do we agree with that? Do we get 3.84? So we have 3.84 seconds. The second part, or the other bit, said find the distance OA. So I'm going to use the answer. If we think about the horizontal motion, we've got 0 acceleration, constant velocity. The velocity was 55 plus 20. So the distance travelled, the distance OA, is 55 cos 20 multiplied by t. So 55 cos 20 times our 3.84 was 198 meters to 3 significant figures. And there we are. That's quite straightforward remarks. And again, you did really well with that. The speed and direction of the ball, 2.6 seconds after the golfer strikes the ball. So in order to do this, the ball would be in motion at that point, because that's during the time that the ball is in the air. So I need to find the horizontal and vertical components of that velocity and then work out the resultant speed. So if I think in part 2, let's consider the vertical motion to start with. T is 2.6 of course now. So I said vertical, I've just drawn a horizontal arrow. We'll do that one first then. So the horizontal, we've got constant acceleration of 0. We've got 0 acceleration, constant speed. So the velocity, the horizontal component, the x component of that is going to be the same as it started, which was 55 cos 20. If we think about the vertical direction, we're going to have to use, what do we need from this? We've got v squared is u squared. No, that's not the right one, is it? What do we need to use for this one? V equals u plus at. That would work, wouldn't it? So let's use v equals u plus at. So the vertical component of that is the initial vertical component of the speed, 55 sine 20, minus 9.8 times 2.6, which gives us, and I saved this in the memory of my calculator, it was minus 6.67 to three significant figures. So we've got that it's 55 cos 20 that way, 6.67 that way. So the resultant, the velocity that we want, is the square root, Pythagoras theorem, of 55 cos 20 squared plus 6.67 squared. I'm going to use the stored in the memory of the calculator number, and it gives me 52.1. Do we agree with that? Meters per second. I then need to talk about the direction of that, and I decided to label the direction. It didn't tell us, did it? It just said the speed and the direction of motion. So I'm going to work out that angle, call that angle theta, then tan theta is opposite over adjacent. So that gives us an angle of 7.35 degrees. So it's 52.1 meters per second at 7.35 degrees below the horizontal. And that's enough for all of our marks. That's maths.